Good afternoon, one and all present here. Today we have discussed about the topic of time domain specification, the model category of module name time domain. Okay, so what is time domain specification? So desired performance characteristics of control systems are specified terms of time domain specifications. The desired performance characteristics of control systems are specified terms of time domain specifications. The transient response characteristics of control system unit step input as specified in terms of following time domain specifications. What are specifications? Delay time, rise time, peak time, maximum output, and settling time. These are the specific parameters of time domains. So this is a damped oscillator response of this curves on the figure. This is called rise time, delay time. This max peak oscillator is available tolerance. Okay, this is peak time. This is settling time. The damped oscillator response of the curve. So the time domain specifically defined as alluded to delay time. See, delay time is nothing but time required for the response to reach the 50% steady state value from the first time. This is called delay time. The rise time is a time required for the response to reach to 10 to 100% of final value. This is applicable only for the under-damped system. For all over-damped system, consider duration 10 to 90% of the final value. Here the rise time is denoted by TR. Okay, peak time is a time required for the response to reach the peak value for the first time. This is called denoted TP. And peak overshoot, the peak overshoot MP is defined as deviation of the response at the peak time from final value response. This is called as maximum peak overshoot. My TP will be T infinity will be C infinity into 100. And settling time is a time required for the response to reach the steady state and stay with the specific tolerance bands around the final value. In general, the tolerance bands are 2% and 5%. So denoted settling time is TS. This is a secondary response of various damping ratio. So the poles in the imaginary axis is a response. These poles on this less than the tau value also 0. There is 0 to 1. This is complex poles. The response undamped. This is underdamped. This is undamped response. Tau equal to 1 is the poles in the real axis. Is the critical damped. Tau is greater than 1 is called over damped. The secondary response of various damping ratio at this point. Is a derivations of rise time. So how will find out this? You take this unit response under damped system. So based on this, the derivation got this. Okay, here that value you equate this 0. This is not equal. Only this part. This is cannot be equal. Only this part is equal means you find out this rise time expression. Okay. Similarly, you find out peak time. Similarly, use the derivation peak time. The derivation peak time. The equation is the peak time equation pi divided by omega and y square. So similarly for peak overshoot, derivation is available here. And settling time, here the settling time for that based on the percentage you mentioned the settling time. You see this for 20% settling time is 4 divided by tau omega n or 40, and settling by 5% is 3 divided tau divided. In generally specified settling time is ln error divided by omega tau omega n, the general formula for settling time. Next. Right. Yeah. So I will give one problem. So the closed loop transfer function certain in feedback is given below. Determine what type of system given. You find what is under damped. How will you find out? How will you find out? C of S transfer function is given. So you find out this. How will you find out? Right. Okay. You compare this equation. First you find out this omega n. You find out, you take this is map this, find out this omega n square over 2.8. So this is 2 to omega n, this is 3. You know this omega substitute tau value is 0.53. Okay. The value is tau is 0.53 is less than 1. Okay. So what type of system? Anyone will guess this? So tau value 0 to 1 means what is the type of system? You see this 1. 0 to 1, that range, the what type of system? I see this is for under damped system tau value. Right. Some style is moving. Right. So this system is under damped system. Suppose tau is 1 means it's a critical damped system. In this way, you have to identify what type of system. So the problem is asking determine type of damping system. So here the tau is only 0.53. So it between range of 0 to 1. This is called this system is under damped system. Okay. Do you have any doubt regarding this? Finding what type of system regarding this? Okay, thank you.